All right, so now 6.8 quadratic trig equations. Again, we're going to use a x substitution type strategy. Notice it's a quadratic, so we're going to be dealing with things that are squared and also have other sign functions. So as our strategy was this previous unit, we're going to go ahead and simplify this problem. So let's just go ahead and say that x is equal to sine of theta. So if we know that x is equal to sine of theta, we're going to have 2x squared minus 3x plus 1 equals 0. Well, now we have a quadratic. We know solving a quadratic, we first set it equal to 0. I'm going to solve by factoring. So I'm going to get 2x. X has to be 1. Middle term's negative, so both these signs are negative. This is equal to 0. Then I use my zero product property and say, all right, 2x minus 1 must be equal to 0, and x minus 1 must be equal to 0. So therefore, x is equal to 1/2, or x is equal to 1. Okay, so I solved out that quadratic for x. Well, again, I need to remember I'm solving for a theta on an interval from 2 pi. So now I take this college algebra problem and now bring it back to the context of college trig. So if sine of theta was x, I'm going to say sine of theta now. That was our x is equal to 1/2 from here. And then I can say sine of theta is equal to 1. Now doing these two, I'm going to go ahead and solve them out before. I'm going to draw my unit circle. I know that sine of theta being 1/2, sine is positive in quadrants 1 and quadrant 2. And this is going to be a reference angle of pi over 6. I get 5 pi over 6 here. And then I'm going to hit those on every 2 pi interval. So for this theta, I get equal to pi over 6 plus 2 pi k, and also equal to 5 pi over 6 plus 2 pi k. And now I'm actually going to have a third solution here. Sine of theta is equal to 1. Well, that's equal to 1 here. So theta can be equal to pi over 2, and then every revolution after that. So if I just want on the single interval from 0 to 2 pi, I'm going to get theta is equal to pi over 6, pi over 2, 5 pi over 6, and then all the other ones will be over 2 pi. So I have my 3 solutions there. So let's go on and try another one. For our second example here, notice that we have cosine and sines here. So somehow we got to be able to just substitute in for one value of x. Well, remember our Pythagorean trig identities that we had sine squared theta plus cosine squared theta was equal to 1. Well, I can't necessarily substitute cosine in for a sine equality, but I do know that the sine squared theta, if I subtract this, I want to actually write it in terms of cosine. So if I subtract this over, I get sine squared theta is equal to 1 minus cosine squared theta. So if I do that substitution, I can do 3 cosine of theta plus 3 equals 2. Substitute this in for that, because that's what sine squared theta is, and I get 1 minus cosine squared theta. From there, I can distribute that through, and I get 3 cosine theta plus 3 equals 2 minus 2 cosine squared theta. Well, now that I only have cosines available, I can start doing my x substitution. And I can say, all right, let's let x equal cosine of theta and see if we can get a quadratic that we can solve out here. So I get 3x plus 3 equals 2 minus 2x squared. All right, so solving a quadratic, I want to set it equal to 0, so I'm going to minus 2 plus 2x squared minus 2 plus 2x squared on both sides. I get 2x squared plus 3x plus 1 is equal to 0. Now that I have it set equal to 0, I can factor and use my zero product property. So I got 2x, x, 1 and 1, both going to be addition. So I can see that to make this equal to 0, this is going to give me x is equal to negative 1/2, and this x is going to be equal to negative 1. So then from there, I am going to go ahead and do my x substitution here, and I can say that the cosine of theta is equal to negative 1/2, and that the cosine of theta is equal to negative 1. So now I solve these problems. So I can get my theta between 0 and 2 pi. Well, looking from my unit circle, I see that theta can be equal to, it's a reference angle, so unit circle, I get 1 here, cosine's negative in quadrants 3 and 4, reference angle of pi over 3, so I get 2 pi over 3 plus 2 pi k for my general solution for that one, and then I also get the third quadrant angle, which is going to be 4 pi over 3 plus 2 pi k, and then my general solution for the other one is going to be, well, cosine is negative here on my unit circle, and so that means that theta is equal to pi plus 2 pi k. Wanting just the solutions from 0 to 2 pi, I get theta should be equal to 2 pi over 3. Trying to put them in order from smallest to largest, I get those as my 3 possibilities as solutions to my quadratic trig function. That's the notes for tonight. Hope you enjoyed. I'll see you in class tomorrow.